Schemas are organizational units used to organize our objects. Instead of one schema, we can place many tables, views, triggers, functions, and so on, and we can have several schemas. So schemas are used to group and organize our objects. On this image here, we can see one server machine, and in that server machine, we have installed two server applications. We have SQL Server and we have Monet Server. Now, organization in these two servers is different. Inside of SQL Server, we have databases. So inside of server application, we can have several databases, and each database can have several schemas, and inside of schemas, we have objects. On this image here, we can see that we have database 1 and database 2, and then, for example, database 2 is divided into schema 1 and schema 2. But in Monet Server, we don't have databases. Our server application is immediately divided into schemas, and that is a difference. Now, between server applications like SQL Server and Monet, we have total independence. So they have nothing in common, but the same thing can be said about databases. Databases are pretty independent. For example, each database is a separate process. Each database has its own system tables and storage structures. When we want to connect to a new database, we have to create a new connection, and we cannot query tables that belong to different databases. So what is common for databases inside of one server application? Well, some settings are common. For example, settings about CPU, memory, disk quotas, cache size, and so on. And if we want to access databases, then we have to use the same hostname or IP address if those databases are on the same server. So that is what is common for databases. Now, schemas are different. Schemas are just logical structures. They are not really independent. And why are we using schemas? Where schemas allow us to organize our objects. For each schema, we can differently set access rights and security. Then schemas allow us to have tables with the same name, but those tables have to belong to different schemas. For example, inside of this schema and this other schema, we can have a table like this one that has the same name. But because those tables are in different schemas, there is no conflict. And we can create one select statement that will query tables from different schemas, but only if we have access rights for those different schemas. If we want to get a list of all of our schemas, then we have to go to terminal, and we can read from this system table sys.schemas. And here we will see all of our schemas. Only this schema here is user schema. Other schemas are system schemas. Now, from all of these schemas, only one schema can be current schema. Current schema means that we don't have to use fully qualified names to use objects from those schemas. For example, we don't have to say select a star from schema.table name. We can just say select star from table name. We don't have to use fully qualified name schema.table name, just table name. And also, if we create a new table and we do not specify a schema for that table, then that table will be created in the current schema. So what is our current schema? Well, for that we can use this select statement, and this will give us our current schema, and our current user is VOC. So we have a VOC user that is using a VOC current schema. Now, if we want to create a new schema, then we use create schema statement. So I will now create a new schema. I will run this, but this will fail because our user VOC is just an ordinary user. He cannot create a new schema. Only administrators can create a new schema. So I'm going to quit this session, and then I'm going to log in as an administrator. So I will run this, and my password is MonetDB. So now we are logged in as administrator, and we will now check what is a current schema for administrators. And for administrators, current schema is actually sys. And we will change this. We will change current schema with set schema statement. So we can change current schema for this session for administrator, and we will change it to VOC. I just want to tell you that VOC used here is the name of a schema. But VOC use here is the name of a server. We are logging into server VOC, and inside of it we have VOC schema. So these are not the same things. I will now clean my screen. We are now ready to create a new schema. I will create a schema with the name VOC2, and then I will create a new table. And this table will be created without using fully qualified name. So I will not say in what schema I will create this table. I will just run this. And now I will try to read from that table, but I will search for that table inside of my VOC2 schema. If I run this, I would get an error. And that is because this table is created inside of current schema, and current schema is not VOC2, it is VOC. If we want to create a new table inside of VOC2 schema, then we have to fully qualify its name. So we have to write it like this. In this case, we would create a new table inside of VOC2 schema, so we can read from it like this. Again, we have to use fully qualified name, and this is our table. And now we have two tables with the same name. We have one table that belongs to VOC schema and one table that belongs to VOC2 schema. I will now insert some data inside of these tables just to make a distinction between them. So inside of a table that is inside of VOC schema, I will insert value VOC. And inside of this other table, I will of course insert the value VOC2. Now we have a distinction between our tables, and now we can see what will happen if we read from our table without defining its full name. So we are just saying select star from new table. In that case, we will read from a table that is inside of a current schema, so we will just get VOC. If we read from this second table, then we have to provide a fully qualified name to get VOC2. It is also possible to change current schema. We can do that by using set schema VOC2. Now this is our current schema, and if we now read from new table without specifying its full name, then we would get a value from the table that is inside of our current schema, and our new current schema is VOC2, so that is why we are getting this table with VOC2. It is possible to read from both of these tables at once, so we can have a select statement that will read from this first table and from this second table, and we are currently admin, so we have right to read from both of these schemas, and that is why we can create such statement. So I will run this, and I will get both the value VOC and VOC2. But if we were an ordinary user, for example, if we were a VOC user, then this statement wouldn't work. We would get an error message because VOC user doesn't have access rights to VOC2 schema. I will now clear my screen. If we read from this view information schema schemata, I will run this. We will see that for each schema, owner is admin. And this is because admins only have right to create schemas. But we also know that the user VOC has authorization over this schema. So where we can find that information? Well, for that, we can read from system table sys.schemas. So we can go here, I will run this, and here we can see that for VOC schema, authorization is by this number, 7109. So what is this number? Well, to find out, we will have to read from this other system table. So we will read from system table that is about users, sys.users. So if I run this, we will here find that number. So our user VOC is represented by this number, and this number is actually number of a role. Now this default role is something that is bind to this user. So no other users can belong to this role. This role is created when this user is created, and this role is used to represent this user. So now we know that this user has authorization over this schema. We can also notice one more thing. We can notice this column default schema. For example, for user VOC, his default schema is 7110, and we can find that schema here. So this is his default schema. When we log in as a VOC user, this will be our initial current schema. Similar to that, admins have initial current schema 2000, and 2000 is sys schema, and we saw previously that the initial current schema for admins is sys. If we go back to some of my earlier posts, we will find a statement like this one. So this is a statement we have used to create a VOC schema. When we created that schema, we gave authorization to VOC user. But previously, when I have created VOC2 schema, I haven't used authorization subclause. I only typed create schema VOC2. In that case, a creator is admin, and because of that, this schema VOC2 will actually belong to admin. We can see that here. VOC2 schema has authorization 3, and 3 is admin. So when we do not provide authorization, then authorization will go to the one who created that schema, and in this case, that would be admin. Now, when we create a new schema and we use this authorization, after authorization, we can use a name of a user or name of a role. And what is important is that when we create our schema, then we can provide authorization, but we cannot change it later. So it is important always to give authorization to a role, not to the user, but to the role. And this is always the best solution, because then we can easily add or remove users from that role. And that is how we can decide who can control that schema, who can create tables, delete them, or read them. I will now clear my screen. It is not possible to create a new schema without providing a name. But we can provide that name indirectly. We just have to use authorization subclause. If we run this will be successful. And if we now read from schemas table, we will see that we have a new schema. And that schema has the same name as the role or user that has authorization over our new schema. So this is how we can easily create a new schema with the same name as a user or role. Next, we will see how to change the name of a schema, and for that we will use alter schema statement. So I will rename my schema from VOC2 to VOC3. I will run this, and this is successful. But this will fail if I create an object that is dependent on the name of a schema. For example, I will create a view, and this view is dependent on the new name of a schema VOC3. I will run this. This is successful. Now we have an object that is dependent on the name VOC3. So if we try to change the name back to VOC2, this will fail because we have that dependent object. Next, we will see how to delete a schema, but I want to delete this schema VOC3. So I will change now my current schema to VOC, because if VOC3 schema is current schema, then it cannot be deleted. So I will change my current schema, and only now I will try to delete VOC3 schema. I will try that, but I will fail. I have dependent object, and that dependent object can be that view. So I will delete that view, and for this deletion I have to use a fully qualified name of a view because my current schema is VOC. So I will run this. Our view is gone. Can we now delete our schema? Well, we will see that it is still not possible. And it is not possible because inside of this schema we have that table, new table. And this is all because our drop schema statement has the default mode restrict. So this statement here is the same as this statement here. We are always using restrict because it is default, and because of that we cannot delete our schema. But if we want to delete a schema with all of its dependent objects, then we have to change mode to cascade. So this will succeed. If I run this, this will delete schema and the table inside of that schema. And the last thing I want to show you, that we have a version of create schema statement that will never return an error message. And that version is using this subclause if not exists. So this statement will always return operation successful. And we also have such modification for drop schema statement. Then we are using if exists. And again, this statement, just like this previous one, will always return operation successful.